Okay, in example 2, again, our technique here is we bring over the 8 over x less than 0. So when is x minus 2 less than 8 over x? A rational inequality. We get a common denominator of x. So we'll have x squared over x minus 2 times x minus 8 all over x less than 0. The technique here, like we did with the polynomials, we were interested in finding the roots because the sign changed at the roots. So the numerator we will aim to factorize, which we can do thusly, if that's a word. Okay, and so again, we keep the denominator because it may be a key point where there is also a sign change. So our possible sign changes at x equals 4, that makes this 0, negative 2, or possibly 0 in the denominator. And so the technique here is to lay down a number line that includes these values 4, negative 2, and 0. And we'll test some values to the left and right of them, see what's going on with this expression here. So throw 0 in the middle here. 1, 2, 3, 4, 5. 1, 2, 3, negative 1, negative 2, negative 3. So our key values here are negative 2. So maybe just a little dashed line, 0, and 4, 2, 3. And so we are interested in determining what are the signs of these expressions between the different intervals where our key points are. So if we consider, let's consider 5. Let's consider to the right here. When x equals 5, what happens to this expression? Well, we can rewrite it here and we can think about the values that we're going to input here. And so when x equals 5, what would the signs of each of these brackets be? Well, 5 minus 4, that's 1. That's going to be a positive. And 5 plus 2, that's a positive. And 5 on the bottom, well, that's a positive. So positives multiplying on top divided by a positive. That's a positive output. Okay, so this expression in this area will be in fact greater than 0. So that gives us information. Let's test another value. Let's test a value between 4 and 0. Let's test 1's a nice number. So 1 minus 4, that's a negative. 1 plus 2, positive. And 1 on the bottom, that's also a positive. So we have a negative on top divided by a positive. That is a negative region. Okay, so we keep doing this for each region and we fill this out. Test negative 1. And you just got to be careful with your math here. Negative 1 minus 4, that is a negative. Negative 1 plus 2, that's a positive. Negative on the bottom. Negative divided by a negative will be a positive. So these these take a little bit of time, but it's being slow and methodical, bringing over everything to one side, common denominator, factoring, determining your key points, and then testing out the values in the expression. So one more, negative 3 is a good choice. And again, I could choose something, negative 10, whatever seems convenient. So this will be a negative, this will also be a negative, and that will also be a negative. So we have a negative times a negative, that's a positive, divided by a negative, be negative. And so here are our regions. This expression is less than 0 when we are less than negative 2 and between 0 and 4. So the answer is x belongs to the interval of less than infinity, negative infinity to negative 2, or between 0 and 4. And again, we don't use the squared brackets because we are concerned with being less than 0. at 4, this expression is 0, so we're not concerned with being equal to 0.